Hello everyone, welcome to this detailed video on K-Nearest Neighbours, commonly known as KNN. If you are someone learning machine learning, KNN is one of the simplest yet most intuitive algorithm to start with. In this video, we will go step by step from what KNN is, how it works, its real world application to its Python implementation. और सब कुछ एक्सप्लेन करेंगे इन अ वेरी सिंपल एंड रिलेटेबल वे सो लेट्स गेट स्टार्टेड KNN or K nearest neighbor is a type of supervised learning algorithm. Supervised का मतलब होता है the model learns from labeled data where we already know the correct answer. And there are two types of machine learning algorithm. One is supervised and another one is unsupervised. KNN can be used for both, like in supervised learning there are two types of algorithm. One is classification and regression. KNN can be used for both classification as well as for regression. KNN can be used for classification where we assign categories जैसे कि spam or not spam, pass or fail, and regression where we predict continuous values like price or temperature. But KNN is most commonly used for classification problem. What's interesting about KNN is that it is a lazy learner, meaning it doesn't explicitly build a model during the training phase. Instead, when a new data points come in, KNN compares it to the existing training data and makes a decision based on the K nearest neighbor. Let's start with basic intuition. Imagine a 2D graph where we have two types of points, red and blue points. These represent two different classes in our data set. अब suppose एक नया point आता है and we don't know whether it belongs to the red class or the blue class. So KNN says, look at the k nearest points around this new data. For example, if you choose k equal to 3, then you check the three closest points. अगर उनमें से दो या तीन ब्लू हैं तो प्रिडिक्ट ब्लू, अगर रेड ज्यादा है तो प्रिडिक्ट रेड. इट इज लाइक आस्किंग योर क्लोजेस्ट फ्रेंड्स फॉर एडवाइस. Majority wins every time. And that's how KNN classifies new data points, simple yet effective. Now let's break down exactly how KNN works step by step. First step is choose K. This is the number of neighbors you want to consider. K is a hyperparameter that you decide based on experimentation. Second step is calculate the distance between the new data point and all other points in your dataset. We will talk about distance in formulas next. Third is identify the K nearest neighbors. These are simply the points with the smallest distance from your new point. Fourth, decide the output. For classification, you choose majority voting. जो क्लास है उनके पॉइंट्स में वही प्रिडिक्शन होता है. और रिग्रेशन, फॉर रिग्रेशन you take the average value of those k neighbors. The best part is no explicit model building, just store the training data and use it directly during prediction. Distance calculation is at the heart of KNN. To decide which neighbors are nearest, you need to measure distance, and for that, there are multiple formulas. First one is Euclidean distance, the most common one. It is the straight line distance between the 2 points. It is like the Pythagoras theorem in action. Second is Manhattan distance, distance along the axis, like moving on a grid in a city. That's why the name came as Manhattan distance. Third one is Minkowski distance, a more general form where you can tune how the distance is calculated. And the last one is cosine similarity. Instead of distance, it checks how similar the direction of two vectors is. It is the most commonly used similarity. and it is used in text data or document classification. Remember, the right distance metric depends on your data set and the problem type. Let's take a practical example to make this crystal clear. Suppose you have a data set of student and there are only two columns. First one is our studies and second one is a result. Result है pass या fail. So here is the data. Let's suppose there are data where if it is 1 hour, then it is fail, 3 hour, then it is fail, 5 hour, it is pass, 6 hour, it is pass. So when a new student studied for 4 hours, what you will predict? You want to predict whether they will pass or you fail. We calculate the distance from this new point, which is 4 hour, to all the existing point. So distance of 4 hour from 1 hour will be 4 minus 1, that is 3. From 3 hour will be 4 minus 3, 1. From 5 hour will 1. From 6 hour it will be 2. We are just subtracting it. If we take k equal to 3, the three nearest are 3 hours, 5 hours and 6 hours. 3 hours is fail, 5 hours is pass and 6 hours is also pass. Majority is pass. So we predict that the student will pass. Simple, logical and completely based on existing data. K का selection बहुत crucial है. If you choose k equal to 1, the model becomes very sensitive to noise. एक गलत point can lead to wrong predictions. If you choose k is equal to too large, you may lose local patterns as the model average over too many points. So how to choose k? Prefer odd numbers of classification if you have binary classes. You can use techniques like cross validation, where you try multiple k values and pick the one with the best performance on validation data. Choosing the right k is more about experimentation and understanding of your data. Like every algorithm, KNN has its strength and limitation. So its strength is it is extremely simple and intuitive. No model training time is required. That's why it is called lazy learner. It works well for small to medium data set. And the limitations of KNN are it is slow during the prediction of large data set because it calculates distance to every point. Performance degrades with high dimensional data, which is called curse of dimensionality. Sensitive to irrelevant features and different feature scales. So pre-processing is essential. So KNN is powerful but only when used with extreme care. Now let's see how to implement KNN using Python scikit-learn library. It is literally just a few lines of code. First, you import the class, then you set k, then you fit the model with the training data, and then predict on test data. But don't forget, before fitting the model, always scale your features using standard scaler or min max scaler. Otherwise, distance calculation won't be accurate, especially when features are on different scales. KNN is not just for academic practice, it has tons of real world applications. कुछ applications देखते हैं इसके. First है recommendation engines. Netflix, YouTube, Spotify suggest similar content using KNN like approach. Second is handwriting recognition. Classifying handwritten digits or letters can be done by KNN. Fraud detection, detecting unusual transactions by comparing to historical patterns, can also be done by KNN. Medical diagnosis, predicting disease based on patient data and historical classes, can also be done by KNN. Anywhere similarity matters, there KNN can be applied. A few tips to boost your KNN model's performance. First one is always normalize or scale your features. Unscaled data can mess up distance calculation. Second is consider using PCA, yani principal component analysis, to reduce dimension, especially in large data set. Third is for large data set, use optimized data structure like KD tree or ball tree to make distance calculation faster. And the last one is use grid search cross validation to find the best K by testing multiple values on validation sets. These best practices can take your KNN model from average to excellent. Let's quickly recap. KNN is a supervised lazy learning algorithm. It predicts based on majority of nearest neighbors using distance calculations. It is simple, interpretable, and works well with small data set, but it needs proper feature scaling and struggles with large or high dimensional data set. Used smartly, it is a powerful tool in your ML toolkit. That's end of this video. Thank you so much for watching this video on KNN. If you like this video, please do like, share, and subscribe. If you have any question or suggestion, do let me know in the comment section.